This is problem 13 of chapter 11. It's also a problem I think we're going to do in class. So let's go over it real quick. So you take a quiz with 6 multiple choice questions. After you studied, you estimate that you would have about an 80% chance of getting any individual question right. What are your chances of getting them all right? Your simulation should use at least 20 runs. For this video, to keep it short, I may do 10. Let's just see how it goes. Okay, so the component, that's the sort of like this, the one thing that happens over and over again. So the component is just going to be answering one question. Sorry, this electronic pen is weird. One question. Okay? Now, the outcomes are pretty straightforward. You're either going to get the answer, so you have a correct answer, or a wrong answer. All right, so now we're gonna do that 6 times. So for one trial, we will generate 6 random single digit numbers. Okay, so now let me just stop there for a second. The reason I say single digit is that the probability of success, let's call that P, is 80%. Probability of failure, let's call that Q, is 20%. And the number of samples, so to speak, or the number of components, 6. Okay, so to represent 80%, we can use single-digit numbers. So let me just say here, assignments. I'm going to say from 0 to 7 is a correct answer. Okay, and I'm going to say from 8 to 9 is a wrong answer. All right, so I could go, if I could say from 1 to 8 is correct, but then I would have to say 0 and 9 are wrong. Okay, so there's more than one way of doing it, but so be my guest, do what you want. For one trial, we will generate 6 single-digit random numbers. Okay, see, we will count the number of correct answers. Via the assignments. Almost every time I do a simulation, if I do it again, I'll write something different. So there's lots of different ways of writing a procedure. Okay, so here the important thing is here, we don't have to say to ignore any of the numbers, and we don't have to say ignore the repeats because a repeat is fine. Okay, so there's nothing unordinary that we have to do here, and the stopping condition is pretty clear. It's after we get just answer 6 questions. So we're good to go. The response variable, though, is this is always a good time to stop. That's where we pull it out instead of burying it into trial description. I make it explicit. Because what you want to do is you want to come back up here and just sort of make sure, what are we trying to do? So the question we're trying to answer is, what are your chances of getting them all right? Okay, so the response variable is counting the so answering or counting the number of that are right, or let's see, how would we put it? Let's just say checking to see if they are all correct. All 6 questions. Okay, so there's probably some of you that can figure out a better way to write that, but anyway. So now let's here. What I've done is showed you, or I'm doing it how a test would be done. So I've already got the numbers here. So what I'm going to do is say notation, and I'm just going to make sure the reader understands. It should be apparent, but just don't assume that. Correct? And W would be wrong. Alright, so now we have to do 20 trials. So what I'm going to do is just say T means trial. So for trial 1, we have correct, 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 correct. So all 6, put a little check, all 6 are correct. So for trial 2, correct, 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 correct. Okay. T2. So for T3 though, I see an 8, so correct, wrong, correct, wrong, correct, correct. Okay, T4, and so on. So what I'm going to do is I'm going to stop the video, go ahead and do this, and then come back to it. So I've gone ahead and run all 20 trials, and I tried to follow the notation. It's pretty sketchy. In fact, it got so scrunched up that I skipped row 3 and just moved on to row 4 just so I had some room to write. Anyway, we said we would check to see if all correct, all 6 questions. So what I did was my response variable in this case is really just circling, counting to see if they're all correct, and then circling the ones that are of the trial. So I've got 8 out of 20. So in this case, there's not really a response variable. Usually I would write RV and kind of like, you know, define it for each trial. You could put a 6 if I wanted, but that's not necessary in this case. It's too simple. So what we really are interested in is a statistic to answer the question. And so in this case, the statistic is 8 of 20 trials produced, I guess, what? Produced, maybe I should say had, all 6 questions answered correctly. So that's do a little algebra. 8 out of 20 is 4 out of 10, right? So that's 40%. So there's my math. So according to the simulation. Let's go back up and see what the question was. Let's just make sure. What are your chances of getting them all right? Okay, so according to the simulation, our chances of getting them all right is 40%. Okay, so I've answered the question in context. Alright, so that's all there is to it. We define the component, define the outcomes, describe how we're going to do the trial. Sometimes it's a little more complicated. Then we define our response variable. Then we use notation and run the trial, calculate a statistic from the trials, and then draw a conclusion according to the simulation. Okay, I hope that helps. Good luck.